Good morning to all of you. Thank you for spending the whole day with us. There's a lot of exciting booths and tracks and speakers today lined up. What we'll do in the next 40 minutes is talk about the AWS machine learning and AI offerings, focusing on some of the new things that we announced and launched in the last few weeks. All of you know we have this fairly major developer conference in Vegas called re:Invent. A lot of new stuff gets launched at that conference, and kind of there's a great kind of follow-up to that conference. So with that, let's get started. A bunch of us were here last year, and you heard us talk about this. Our mission at AWS from day one has been, how do you get machine learning in hands of every developer, right? And when we say every developer, it means organizations that have scientists in them, organizations that have aspirant scientists in them, organizations that doesn't have scientists in them. How do you make machine learning and AI available and possible for all different organizations? That has been the charter from day one. And what does the charter mean, right? You'd hear a lot of other providers and services and a lot of talk about features. I think the best measure of innovation is rate of change, right? How many features, how many improvements, how many new launches. Since re:Invent 2017, which is almost a year ago, we have had over 200 launches across the different services that we offer. This doesn't include some of the fairly major quality and feature updates that various teams had made to their stack, which is kind of as an ongoing process, right? Now, you might ask, how, is it like, why are you making these changes? Well, we are making these changes because we in AWS have customers who are running more machine learning than anywhere else in the world. And what that means is a continuous feedback loop. That means a customer, when they're trying a product of ours, call us up, say, hey, that feature is not working how I want it to. That leads us to make changes. That leads us to adding new features. So it's really the customer. And if you look at this customer list here, it kind of crosses across many verticals of the market segments that across multiple industries, right? So it's a very exciting time for us. We believe, as you saw the video before, we're just getting started, right? It's just early days for us, and you'll see a lot more. So let's start with the machine learning stack. This is something that we probably showed you last year, right? We have, at the lowest level, we have our frameworks and infrastructure, and I'll spend a little bit of time talking about it, why that's exciting, what is the plan and vision behind that. We have the ML services, which is helping customers and developers and folks like you to experiment, to create machine learning models and algorithms and inferences really easy. And finally, we have the AI services, where a bunch of us operate in, which is about, can we remove even further the undifferentiated heavy lifting for you, so that you could call a simple API, pass a certain set of assets, and get some responses back. And we'll talk a little bit about them as well. Well, we have added, as you could see here, we've added a bunch of new stuff here. And as I said, over 200 launches. These are all the new announcements that happened over the last few weeks leading up to re:Invent in end of November. And you could see that, both at the lowest layer, at the framework infrastructure level, we have made it a set of compelling features. We have added a bunch of new capabilities in the ML services layer in the middle one, as well as a bunch of very, very exciting set of features and services on the AI services stack, almost on the top. Now, the question you might ask is, what's the rhyme and reason for this? Like, why are you guys building at this fast clip? What is the rationale? How do you choose what to build? Well, the answer is really simple for us. The answer is you, customers, right? And it comes from when a customer comes and tells us, hey, we have this really hard problem. Can you solve it for us? We go after that, right? And we say, okay, let's see if we can solve this problem in a way that customer can get value at a way where they couldn't get anywhere else, at the scale of AWS, at the cost efficiency of AWS, and at the openness of what AWS provides, right? That has been the tenets that we've applied in everything that we have built within this stack. So as I said, we are really focused on not just building services and adding more features. We are building on solving some of the toughest challenges that our customers face today, right? And customers from all different verticals across multiple market segments. And if you look at the world of machine learning today, there are three broad categories of challenges that customers are dealing with. And I'm sure all of you are more or less familiar with this, right? How do you run machine learning ecosystems and services and training infrastructure in a flexible and cost-efficient manner? Right? That's the number one problem everybody's dealing with. As everybody's getting into this bandwagon, how do you do this at a cost-efficient way, right? When I started my machine learning journey, about now almost 6 years ago, a lot of these capabilities were not available. So I had to burn a lot of capital to acquire hardware, which was irrelevant in a matter of 6 months, right? So how do you do machine learning in a flexible and cost-efficient manner? Well, the next step, once you have set up this infrastructure, how do you get data? How do we make it easy for you to get data, access data, have data available for your systems that you need to train, or models that you want to update, or just new systems that you want to build? That's a very important and interesting problem. In fact, we find most organizations spend anything between 60 to 80% of their time today in this space, right? Data wrangling, data annotation, data cleanup, data discovery, feature engineering. That's a big part of a lot of the work that goes in today. Then finally, how do you make it easy? Right? So we got the infrastructure set up, we got the data ready. Now, how do you make it easy? How do you make it accessible to everyone? How do you make sure that there are clearly, no offense to the scientists, more engineers than scientists. I'm an engineer too, so all good here. There are definitely more engineers in this room than scientists. And how do you make it more accessible to engineers? How can engineers, move the envelope further for your organization? And that comes to ease of use. So let's look at some of the new features that we have added. How do they correlate to these three categories of problem that faces customers and some of you in real world today? So let's start with flexibility and cost, right? And if you look at the set of features we have done, I'll get into a bit more depth in each of these. The lowest layer, if you look at the lowest layer of our stack where the infrastructure and frameworks are, we have made sure almost all of the framework that one could possibly think of using or uses is available. It's available, it's highly optimized, it's easy to run, and it's easy to access, right? And that openness, that flexibility is really, really important. And I think it's really important because we all agree that it's early days for machine learning, right? We don't know what machine learning ecosystem would look like 2 years from now. So do you really want to lock into a one solution or a one framework without getting the advantage of the benefits, the computational capability, the performances of some of other models, right? So for instance, you might be using TensorFlow, but maybe there's a RCNN Cafe2 model which performs the best. Like, why do you want to make that trade-off? There's no reason to, right? And that's why the openness and flexibility is really, really important. So if you look at our stack, at the lowest layer, we are supporting almost all frameworks. TensorFlow, MXNet, PyTorch, Chainer. We added Horowitz support along with TensorFlow. There's a bunch of interfaces that we have made available to all of you so that you could easily interact with the frameworks. And that's an important part. That's a very, very important distinction. We are framework agnostic. If your scientist needs to run an experiment on PyTorch and run their production inference on TensorFlow, why not, right? If you have a set of scientists that wants to do a quick POC on a Cafe2, because honestly, the archive paper is written on Cafe2, before figuring out what is the right framework to deploy it in production, why not? Why stop them? Because the translation cost of taking a Cafe2 paper or a TensorFlow paper or an MXNet paper into a framework that you're locked into is not low, by the way. It's a non-trivial effort for you if you want to take a Cafe2 paper and try to figure out how it works in TensorFlow or MXNet, or vice versa. So that openness, that framework agnostic is very, very important as you're getting into this journey. And it shows, right? And again, the proof is in the pudding. We could build all we want to build, but You folks, you customers, keeps us honest, makes us, do the things that we do, and it shows, right? More customers use AWS for operating TensorFlow than any other platform. 85% of all TensorFlow workloads are running on AWS today, and these are some of the prominent customers that are actually running TensorFlow workloads in AWS. And there's a reason for it, right? If you looked at Andy's keynote at reInvent, Andy Jassy, our CEO, he talked many times about we have created these dedicated separable teams that are working on TensorFlow, that are working on MXNet, that are working on PyTorch, and they almost compete among each other, right? So there's always this interesting, fun tussle going on. Well, my MXNet, this framework has improved. The next week, the PyTorch tells me, oh, we have improved this better. That inner competition means good value for you, right? That internal competition, that internal jostle means that's value for you. And it shows. And I'll give you some example. So this is a benchmark, created by our friends in Bay Area. The stock TensorFlow, 65% efficiency with 256 GPUs. AWS actually took that word is supposed to be new, sorry, it got a bit mangled in this display. We have now a AWS optimized TensorFlow in integration with, we integrated parts of the kind of the distributed training aspects of Horvath in it, and we are able to get 90% efficiency on TensorFlow on our AWS instances. And it's already available today if you use SageMaker or use the deep learning Amazon machine instances, which is how most of these frameworks manifest itself. Single click, you could get all these frameworks and all the dependency library available to you. It's available today as part of those offerings. So what does this mean for you? Well, it's cool, good numbers, which means training time is faster. That means you can run more epochs, you can do more training, you can do more multiple parallel training and get convergence faster with this system, which means you can respond to your real business needs, your customer requirements faster, right? Think about everything in terms of how it impacts or benefits your customer, because that's how honestly we think all the time, right? So as a result of some of this change, and you could see that the current benchmark has been that CNN ResNet 50 model takes with 256 GPU was taking about 7 hours, and the time to train it. And with this optimization, now you're able to train this entire thing in 14 minutes. Huge gain, right? Imagine if it's a larger system, a ResNet system that's doing hundreds of million images, that could be in a matter of days. Now you're able to bring it down to a matter of hours. That means rapid decision making, right? That means better value to your customers. If you look at a speech algorithm, the LSTM training, which was benchmarked about 6 days with about, again, the 256 GPU is down to a few hours, right? Huge value again. Let's look at what we are doing with MXNet. Apache MXNet is, a lot of enterprises are saying that for their large scale users, where really distributed systems do matter, the size of the, the models do matter, MXNet seems to be emerging as a clear choice for those customers. You could see them here. We have, keep investing on that. We keep making it run faster on AWS stack. And again, it's available as part of both SageMaker and our deep learning army. Some of the really fun use case, real value use case for Chick-fil-A here. It's a fast food chain in US, and they're able to use deep learning and MXNet to solve some really hard problem that they had in terms of their customer experience that they're delivering. In their sense, customer experience is the freshness of the fries. Who doesn't like a fry here, right? So that's what Chick-fil-A is using MXNet for. The same with PyTorch, right? We have a dedicated separable team that's working on making PyTorch run better in AWS. And again, our investment in these areas, we keep making bigger investment because honestly, I think the openness of the framework, the flexibility of the framework is an important choice that you guys need to have. The other thing we learned is that though machine learning, so far has been a process where you have a scientist sitting in the corner doing the work and spit out a model to you, as we are scaling, it's becoming a lot more collaborative like software development, right? Can you imagine a world where you are writing a piece of code, nobody gets to look at it, you get to deploy it all the way to production, maybe for a one-person startup that happens. But in a large-scale enterprise, imagine the world that you're sitting in your silo, writing a piece of software, testing it by yourself, pushing all the way to production. Will never happen, right? You need other people to do code review, you need other people to check your code, version control. Well, machine learning is kind of getting there at this point, has already gotten there actually, and it's become largely collaborating. And what are we doing to help there? So with SageMaker, we are now supporting experiment management so that multiple scientists can track and manage and monitor experiments and have a very cool search capability that you could use to see, hey, what other person is running a deep learning RCNN model, and what is the current state of that training and what are they doing. Lot more features around collaborating, right? Be it version controlling, be it using repository, using both public and private repositories, as well as better access control. And then finally, more automation, right? If you are familiar with step function, now SageMaker very naturally integrates with step function because you could create workflows, as well as Apache Airflow is quite popular in terms of creating these sort of systems. There's a native integration with Apache Airflow too. So we talked about the first piece, which talked about the flexibility and cost and what we have done with SageMaker, with our frameworks. Let's look at what we are doing for data. And I think two big things to call out here. We have made a big investment because we believe reinforcement learning is a big part of dealing with a lot of the complex problem that you have to deal with in different verticals, and we'll talk a little bit about it. As well as we have created a new solution called SageMaker Ground Truth, and I'll tell a little bit about that. So again, as part of the SageMaker ML services offering, we are added a new capability called Amazon SageMaker Ground Truth. Imagine the world where if, the world I live in, right? I had to go figure out, take millions of images, and then had to have human being go and annotate these images to say where there's a dog, where there's a cat, where there's a car. It was a very, very tedious process, and we are far from being done, by the way. We have been this for years, and we are far from being done, right? And I'm sure you guys have the same problem, be it in language annotation, creating annotation for languages, creating annotation for documents and images, or just basic, simple data. How do you get annotation? How do you make it fast? How do you make it easy? Now, we have always had this offering for many years now called Amazon Mechanical Turk, which allowed you access to a wide pool of human workforce. Well, that only solved part of the problem because you still had to deal with creating these workflows to create this work in front of the workers, get their responses back, manage the data sets, a lot of undifferentiated heavy lifting. We have removed it from now for you. So you can quickly create a label training data set using Ground Truth. It easily integrates with human labelers. It could be the MTUR, the public workforce. You could bring your own workforce, or there's a set of vetted vendors that you could pick from easily. And the idea is that you get much, much higher accuracy annotation without doing any plumbing. So you just bring your data set back, you provide your data set, you say, I want this label of this data set, the work gets submitted. We are using machine learning in active learning loops in there so that we are able to create much higher accuracy results for you. So now you have highly accurate annotated ground truth data that you could use for your SageMaker model training. So that's awesome. So now we solved the problem. If you need data, we have some, a bunch of supervised learning algorithms available. SageMaker, you have got your data, you could get it training. But there are a lot of environments that, you don't have data, right? And by the way, this is a very simplified diagram. So if any of your scientists, please don't yell at me after this session. I see a couple of folks in the front give me dirty looks. This is not exact. But the simplified view of the world is that if you have a lot of amount of labeled training data, a priori information, then you will apply, and the complexity of decision is high. You would use supervised learning. Easy, right? This is image classification, language understanding, all this NLP, NLU. These are the classic domains of this problem. On the bottom left is when you don't have a lot of data, The complexity of the decision might be a little lesser, and you use unsupervised learning, and there's a bit of a kind of a semi-supervised learning that goes in between those two spaces. And of course, if the complexity of the decision is not that high, and even if you have a lot of data, does automation really make sense, or we left that empty? Where it really gets interesting, that you have a really complex problem, and you don't have a lot of data, right? Now, that's where reinforced learning comes into play. Now, what's interesting is that the real world around us has always been using reinforcement learning for many years now, right? If you look at how a kid learns to walk, they'll get up. There's a lot of gravity that doesn't let them get up, right? They seem to have pudgier hands and legs and cuter heads, so they tend to go down faster. They'll try to get up, they'll fall, pain, negative reward. They'll say, oh, that's not good. I need to figure out how to stand. So they'll get up and they'll try to just balance themselves. They'll figure out how to not fall the first time, right? That's the reward. The reward is they're not getting pain. And so they're learning from this, their state, they being the agent, the state is not falling. And so they keep trying it until the reward is more and more positive, that it doesn't bother me anymore, it doesn't hurt me anymore, so I'm doing something right. The next step then is to get to that jar of cookies, because I really like it every time my parents give me. Can I get to it myself? That's the reward. They're going to try to get to it. They're going to fall. Again, negative, right? The pain, the shame. These kids are really proud, by the way. Every time they fall, they're really embarrassed. Like, oh my God, what would others think of me? Like most of you here too. So they're like, oh my God, I know it's negative reward, right? So they keep trying it until they get to a point that the farther they get to the closer they get to the cookie without falling, that's more positive reward, until they get to the cookie and can pick up the cookie jar. Always there. If you have pets at home, you do this today. Your dog's pee in the floor, you yell at him, if the dog or her, and if the dog doesn't pee, you give them a cookie. The dog quite doesn't know first time why they got the cookie or the treat, but they know there was a positive reward, right? And the next time they pee, they don't get the reward. No, I didn't get the thing. So that's reinforced learning. It's in around us all the time. And you could imagine why that would be so powerful if you could bring into the robotics, into automation, into decision where the data is not always available. Because imagine a robot that's trying to move around this space, because people are squatting on the floor here, and because even if I could map the room with a priori information based on the chair setting, it has changed. I saw some gentleman in the back got in, he was smart, he didn't want to walk in, he just pulled the chair out, walked in, and kept the chair where it was. So it's kind of now misaligned. How do you learn from these sort of changing environments? That's where reinforcement learning comes into play. So the big part, as I said, look at the examples I gave you. You have to learn by interacting with the world, the falling on the floor, trying to get to the cookie jar, not being on the living room, walking around this chair that's been moved, right? To build and to train, you need to simulate a real world. Imagine if I told you to fly a plane, right? I'm not going to ever give you a real plane to learn how to fly, right? I'm never going to do that. I create a simulated environment. I show you how to fly. Every time you break it or fail it, I give you negative points. Every time you fly successfully for 10 minutes, I give you positive point, right? So you want to create that simulated, model the real world environment. You want to do trial and error, right? You want to make sure that your learning strategy is optimized for longer term reward, because the longer term reward is about getting to the cookie jar. It's not about just I walked 3 steps, because that's not what that kid started thinking about. The kid wanted to get to the cookie jar by itself, right? So the longer term reward is more important to maximize your learning strategy for. And eventually, the model learns how to make complex decisions, right? That's really the benefit of it. Now, yeah, I could train a robot that could walk around this space without bumping into any of you or any of the obstructions, because it has learned how to deal with this, make complex decisions. So, as I talked about, right, there's an environment, there's reward function that goes in, and you can now have training data generated, which goes into the environment, gets trained, model gets inputted, model gets outputted, goes back to the environment. So what is an environment? We talked about. It's kind of the space where the kid is walking. It's this room where a robot has to move in. It's that living room where the dog knows not to pee next time, right? And today, the environments can be fairly sophisticated, right? You could use, MATLAB, Simulink to create fairly sophisticated simulation environments for robotic work. Or you could write your own, use Python, you could write your own environments and simulation. So let's show an example how we could create an RL solution. Here we are creating a model, and when I show the picture, I was discussing with Girish here that it kind of looks a bit toyish, but understand the picture is representation of a real human being, right? It's the gravity that comes into human, the weights, the limbs, everything is played, which means if I didn't know how to stand right now, if I didn't learn when I was probably 9 months or 1 year old how to stand and walk, right now you'd see me toppling over, right? It is amazing how do you even think about it. Like, it's just really, really interesting. But we have formed our muscles to know how to stand erect, right? Or slouch a little bit as the case might be, but, more or less erect. So here is an initial model. It's trying to just stay up. It's so hard to stay up for it. And by the way, it might look silly to you, but it's not. It is a real-world simulation of a human in the condition. There's gravity trying to pull you down. There's air pressure. There's friction of the surface. And you are barely trying to stay up. And it's hard, by the way, because this is a 1-year-old kid. This robotic model is a 1-year-old kid. It doesn't know. And this is how the kids behave, by the way, right? So that simulation environment, the agent is that figure stick. It's trying to walk in that simulation environment in a straight line. It's trying to take the action so that it could walk. That's the action, that's the state change that we want. And we are observing how he's doing it. There's a set of reward, which if he walks a few steps, that's positive. If he falls over, that's negative. And that reward function you want to maximize. That creates a training data. That training data can then be moved into SageMaker. SageMaker RL available today. You can do reinforced learning training in SageMaker. That then create a new model. Then you can bring the model back into the simulation environment to see what happens. As a result, some mid-step, look at this. So painful, man. I was feeling so sad last night. I was looking at this video. It looked really painful, this individual. And so basically what's happening, every episode of training, this episode of rinse, repeat cycle, of getting the data, moving into the model, training, getting the model updated, is getting to a better reward function, right? It's moving better, it's moving more upright, it's moving closer, until you get to a point where, there's almost no gain to be had. And that's our baby, walking. We just made a person walk. How proud are we? So now it's walking fairly straight. And by the way, the next level of, if you see this, it's kind of a silly person, he'll just keep walking. Kind of those movies where they don't know when to stop up the race, they keep running after the race is over. So this guy is, but as more complexity can be brought in, it would know how to turn, it would know how to navigate that environment. So that's what reinforcement learning is. You could visualize some of this training information. The trained model can then be deployed in real-world scenarios. So if this was simulated robotics for this environment, you would then actually deploy the model on the robot, and the robot would know how to deal with this environment. So lots of, you could think of anywhere you don't have a lot of a priori knowledge, and do you want to learn from the environment, this is the solution for you. And you could look at across different vertical, be it food delivery, right? I was listening to the folks from Swiggy talking about it yesterday, that they have this challenge of knowing, how to navigate a space because they know where the building is, but they don't know what building security is, where the parking space is. That's reinforcement learning for you, right? Because every reward function would come back, say, hey, it took me 5 minutes more to get to it because I didn't know that information. That's where you could so easily use these sort of things. And again, autonomous vehicle, it's already robotics, largely use games today. A lot of these gaming systems are using reinforcement learning. So it's, you could think of a domain where you don't have a lot of annotated ground truth data, you don't know the a priori information, reinforcement learning could help you. Let's look at some example of this vehicle routing thing. Look at this car moving around from the home station to different delivery, and we are optimizing for speed of delivery, right? This is a simulated environment, we are optimizing for speed of delivery. You could create a lot of, fintech, automated portfolio management is a big deal now. Reinforcement learning can really, really help because market is kind of non-deterministic, right? There is a priori information, to be fair, but beyond a point that doesn't apply because there are so many other variables that gets into it. You could imagine, for us, AWS, how do you auto-scale in an environment, right? You could use reinforcement learning because I'm in a growing business, right? The sort of scale that I have today, I didn't have a year ago. I wouldn't have known what sort of recognition volume I'm going to get 2 years ago. So this is where reinforcement learning to figure out how to auto-scale environments can be extremely powerful. As I said, the power is here, but again, ease of use is lacking. So it's very, very hard to train this model for these reasons. And a lot of customers came to us, told us, it's awesome, you guys keep telling us reinforcement learning, but man, it's so difficult to do it. It's very hard to code these environments up. It's very hard to train this model. It's very hard to plug the end-to-end. It's very hard to keep this model updated. Algorithms are very hard to get to. There are few, but how do you put it all together? And so that's why we have announced SageMaker RL. It's available today. It already automatically supports a bunch of the RL toolkit that you're familiar with. And whatever toolkit is not automatically supported, if you look at the OpenAI baseline, the DQN and the PPO from the OpenAI baseline, you could just containerize and bring it into SageMaker. It'll just support it, right? But we have native support for Coach and Raylib. So the idea is that you could use simulated environments, and we are providing our own. We have Amazon Sumerian, which is a AR, VR simulation environment. We have RoboMaker now, which is for robotics and RPA. You could, again, natively integrate it, and you could bring your own open source environments, again, containerize, and you could bring it to SageMaker. Very easy to do that. You get, of course, again, with everything that we build, you get the scale, you get all the logging, metering, you could do single environment, distributed training, all of that is available. Here's a great example that we use this deep racer robocar training using RL ourselves, using RoboMaker and SageMaker. Some customers that are already starting to use this feature, request you guys to go take a look if reinforcement learning of interest to you. Next thing I'll quickly talk about is a lot of customers came and said, hey, that's awesome, all of these tech you're providing, ease of use, right? The third topic, ease of use. How do you make it easy to use? Well, it's very hard to deploy all this model into these different embedded systems. On the cloud, you have the constraints of time, the time to train, time to annotate data, and blah, blah, blah. And on the edges, on the devices, you have the constraints of resources, computational constraints, memory constraints, heat constraints. How do you marry the two, right? So easy to train a really large model that gives very high accuracy, might be impacting latency, but more importantly, needs a high computational environment. Whereas if you look at a smaller devices, a Raspberry Pi, it needs that low latency and low computational environment models, right? How do you get there? So to build such a thing, you need the Swiss knife of a engineer / deep learning scientist today. Right? They need to understand environment, they need to understand scale, they need to understand deep learning model, they need to understand embedded systems. It's those unicorns are available. Raise your hand if you feel you're one of them, but they're rare. Nobody's raising hand. That was a real request to raise your hand if you're one of them. Oh, there is one person. Awesome. Go hire him. Whoever needs these sort of people. But it's hard to get that. And then you have this really complex ecosystem to deploy these, right? You have to bring all the data to a cloud or a data center or an environment, train them, create a model, then see how the model works in the embedded system. Trial and error, keep going back and forth, optimize, and there's lots to do there, and time consuming. Other problem is this different framework. You take a model in framework that could work really well in Intel and try to move it into FP16, doesn't work. Try to move to NVIDIA, doesn't work, right? These are all software development that you have to do to make it operate. So we have introduced Neo, and what Neo does is that you could train a model in any framework and deploy into any inference embedded systems. And under the hood, what we do, we understand these different frameworks, we understand their construct of these models, we can parse them, we can then figure out the redundancy, we can optimize that model graph to an extent where we could now deploy them and work in very low-level compilers easily. And we actually did some benchmark on the cloud side, running on EC2 instances, and we are seeing significant speed improvements of native trained models on using TensorFlow and MXNet. So that's kind of the ease of use part. Let's talk quickly on the top layer, a few things that we have done in terms of ease of use. We've announced Amazon Tech Stack. It allows you to get a lot of information from scanned and images of documents, which is still the most prevalent type of documents that you get. And what's interesting with OCR was that it's very limiting, right? It gives you left to right, low accuracy, doesn't understand orientation, cannot deal with photometric distortion, which means if you scan a paper, a table looks like a triangle, right? If you try to take a receipt, there's geometric distortion, because it kind of a crumpled receipt has three-dimensional distortion on that image as you take a picture, or if it's folded, the two sides are curving up. How do you solve this sort of problem? What's even more interesting, a lot of these documents are more than just text, right? There are forms and tables in them, and OCR just bungles tremendously. That's why we have TextRact. You might think, why is it exciting? We tend to do it well. We don't actually. More complex form, we don't do well. But more importantly, if you look at it from a computer science perspective, look at these 4 documents, exactly same document, very similar document, but not a single pixel value that's in common across the 4, right? It's a really, really hard problem. 3 features. We can extract the text. Think of it much like an OCR solution. We are able to extract the table information. I'll show a little bit of an example. And we are extracting form from this. So text, much more accurate. So here in OCR, the 2 columns would get mungled into a single output left to right. Here we are able to understand that there's line 1, column 1, and line 1, column 2. It's very, very important. We are able to extract a table and understand the cells, the relationship between the cells, the relationship of a row to the column headers, and so on and so forth. And we are able to identify a form element within the document. So first name with your name and the field values and names, and provide that association as well. So give you an example here. This is what OCR would do. Completely mungle the 2 columnar display of the data left to right, again, bag of words. You have to be lucky to get that extraction. The quality of OCR, all of you know how interesting it could be. And this is what TextRact would do for you. Amazon TextRact would do for you. It would understand the multi-column and say, this is line 1, column 1, line 2, column 2, line 1, column 2. So you could read how a human being would read it. If you have a table like that, we are able to understand, tables that have different variable length and width, and understand the cell information. This is what traditional OCR would do for you, fairly useless. And this is the representation that we are able to get you. So you can now imagine extracting a table from a document and programmatically be able to use this, because the representation in JSON is how you're used to, right? If you look at a form, this is what OCR would give you. Again, the usability gets lesser and lesser as you go through these complexities. With TextRact, Amazon TextRact, we are able to give you hierarchical inference of the association of the word. So we know that its full name has first, middle, and last, and these are the values to it. So the key value representation of a form, very powerful. Finally, in ease of use, we have a few other launches that we made that are very interesting to talk about. We have now launched Amazon Forecast, which is a forecasting solution, fully managed service. You could bring your time series data. We have about 8 different algorithms, if my memory serves well, including 3 of the more traditional approaches available there. You can pick one, we can pick one for you, and then you have a really first-class forecasting API that you could hit and get thing. Now, best part, the data and the model is yours. So you're not sharing your data with anybody else. It's completely your own data and your own model. We also have added Amazon Personalized. This is a recommendation system. Amazon has been building some of the top-class recommendation system for the last 20 years. We have different algorithmic approaches to do recommendation based on what sort of recommendation we are building. We have taken all the lessons learned from within our teams, within Amazon, and we have made that available to you as Amazon Personalized. You bring your SKUs, you bring your data, you bring your catalog information, put it into Amazon Personalized, and you have a simple API endpoint will give you highly accurate recommendations for your need. We also launched Comprehend Medical, which I think is really interesting. Given an unstructured text, it'll give you information like medicine name, dosage, the anatomy, which body part it is about, the PHI, the public, the private health information that you could get. All these entities are naturally extracted from clinical trial, medical journals, or doctor scripts, or pharmacy scripts or whatnot. So that's kind of all the things we have been working on. I want to thank you for the time here, and hope you have a great and productive rest of the day. And thank you.